Okay, nice. So yeah, are there any questions in terms of this Fibonacci sequence? It seems like everyone did a pretty good job. Not sure if you guys actually got those, but yeah, since we are okay, Eric is in the okay. Okay, so yeah, since okay, since everybody is here and no one apparent seems to have any questions, we can move on. Okay, so yeah, so today we're gonna actually talk about sequence in Python, and when I mean sequence, there are three types of sequence in Python. So the first one we have already seen quite a lot. It is called string, and you know, it is a string of character, and it can be treated as a sequence. It is, you know, another it is sort of list. I mean, string and list are pretty similar in Python, and yeah, that is the idea. And list, so we have already deal with it by a bit, but we're gonna officially introduce it. And tuple are something that is new, and the idea of that is, you know, it is pretty similar to list, other than the fact that the tuple cannot be changed once you already defined it. Okay, and yeah, the difference between tuple and the list is that tuple is fixed, but list is flexible. Like for list, you can, you know, add, you know, you can delete, you can do all sorts of things, but on tuple, for tuple it is pretty limited. Okay, but yeah, here is the idea. You can have a list called my list, and then you can just print it out. Tuple works like this. Instead of square bracket, you will use this round bracket. Okay, for tuple. So every time you see a round bracket with a bunch of items in that, then it is just tuple. Okay, so yeah, print my tuple. Okay, so indexing and subsequence. So those are basically very similar to what we have seen, and you can use the same way of like indexing and dealing with subsequent with tuple, right? You can, yeah, let me run this actually. Okay, so yeah, run this, give me a result. Yeah, print my list. The first element of my list, a first element of my tuple, a, you know, the last one. So those are exactly the same, right? And my list from 1 to 3, and then same thing you can do, for example, my tuple, and then yeah, 10 and D. So this is also a little tuple. Okay, so yeah, those are the same. Addition and multiplication. So in terms of addition and multiplication, you can add those two tuples, right? And it does not matter what type of variables are in there. It does not matter. You can concatenate those two tuples, and it will give you a larger tuple. So as you can see here, A tuple is 1, 2, 3, 4, 5. B tuple is 6, 7, 8. Then sum tuple is equal to A tuple plus B tuple, and then you just print it. You can see this. So this is sort of concatenated. Okay, so you can concatenate those two tuples together, and it is the same for list as well. Those are, yeah, I just changed variable type, but without changing the actual value. And you can see here, those are square brackets, those are round brackets. So yeah, you cannot add a list and a tuple. So if any kind of anytime you wonder doing something like this, so a tuple plus a list, because they are or sort of integers, and it does not actually matter, but in fact it does. You cannot add a tuple to a list. Yeah, can only concatenate tuple, not list, to tuple. Yeah, so that is the arrow. Do not do that. Just remember that, okay? And yeah, so when there is only one element in tuple, a comma needs to be added. What does that mean? So if you do a one element tuple and you want to say like a is equal to a string, right? And then whatever that string is, you just put it there, and you use a bracket to actually bracket up, because that is how we usually do a tuple. But what you'll find out is if you want to print type of A, then you still see string, right? And because in Python, think about it. When you do when you yeah, when you do A is equal to 1 and A is equal to bracket 1, there is no difference, right? The bracket does not magically change this to tuple uh, for like one specific element. So there is a case for that, and what you can do is add a comma, right? But like after the comma, there is nothing in that comma, but it is sort of telling the interpreter, which is the compiler for Python, is this is a tuple instead of just adding a bracket um, to like you know it might think as like priority of this statement, but like yeah, so like it will make it a tuple. And if you do like type B here, then you can actually see it is a tuple instead of a string. Okay, so that is that to be keep in mind. So in operator, we have talked about it a bunch of times. I'm just gonna illustrate you again. You can do that for a tuple as well. You can do 1 in a tuple and it will print true. Then if you do 10 in a tuple, then it will get false. Okay, and length, max, and main. So this in terms of this, a tuple is I have a bunch of value here and a bunch of value for b tuple. And then if I print max of a tuple, then you can see 20, right? But when I try to print max of b tuple, there is it will give me an arrow. And what happened? Larger than this thing. This operator is not supported between instance of int and string, and that the reason why is that in our tuple there is a die amount of all the strings, and this is not comparable, right? Because you cannot compare a number with a string. And if I sort of do this, then it sort of works. And yeah, so the max of that will be BB. Okay. Uh, yeah. So if you're curious about that, why the max is BB, then uh, when you compare a string, right, you always starting with the first place, right, on the left. So you're comparing, like, for this case, you can see A, B, B. So both of those two strings are larger than those two strings. Like, no matter how long they do not care, right? It just compares the first letter, right? And since those one are sort of equal on the first letter, then we're actually gonna proceed to look for the second letter, and so on and so forth. Okay, and so BB is like B is larger than A in the ASCII table, right? And I think B has the value 98, lowercase b, and then the the A has the value 97. And ASCII table, if we are not sure, then we can just go ahead and check that out. Yeah, so B has value 98, A has value 97. um, so that is the reason why BB is the largest here, right? And that is not about, like, the length or other sort of factors. And when you're comparing a string, you just sort of take the first letter and compare it, and take the second letter, compare it, and so on and so forth, until you have like an actual comparison of like which one is larger or which one is smaller. Okay, and yeah, so this is similar. I can uncomment this. um, so the least the min of this 8 tuple is 2.4, and then the min of this is the number 9, because the number 9 is actually 57, right? And other letters like those are like 90 something. Okay, so that is why it has the main is 9. Yeah, you can also get the lens. Lens is just I think it's a built-in function, and so does max and min. Yeah, those all three are built-in functions, and you can just call that on a tuple. Yeah, the reason why I use a tuple is that oh yeah, I have example for this as well. Yeah, basically it is exactly the same thing in terms of dealing with those stuff. Okay, so yeah, if I change this example to like 9, then you can see here those are exactly the same. Okay, so sequence packing and unpacking. So that is something new. And when I mean packing and unpacking, it means you have a bunch of values, and when you try to pack it, then it is packed in a tuple, right? You can sort of like thinking of you have three numbers here, and then you just add a bracket outside of them. Okay, and that is sequence packing. And then unpacking just means, for example, you have 10 elements in a tuple, and then you just want to like distribute them into 10 other variables. Okay, it doesn't have to be 10. It will be introduced later. So yeah, you have here vowels equals to 10 comma 20 comma 30, and then you print vowels. You can see a tuple of 10, 20, and 30, right? And then you just print type of vowels, and then you can see it is a tuple. And then unpacking means that you have this A, B, C here, right? And then you're just doing A, comma B, comma C, and then you have like equal to vowels, and then those vowels are just gonna distribute to A and B and C in order, right? So if you print A, you'll get 10. You print B will be 20, and then you print C will be 30. Okay, and then with those two, you can do something like this. So more values equal to A, B, C, D, right? So this basically is actually you pack those four variables into a tuple, and then you assign it to this idea of more vowels, and then you just print that, and then you'll get all those four numbers. Okay, so that is sequence packing and unpacking. Okay, so yeah, with packing and unpacking, we can do this. So what happened is, uh, you look at the right side of the expression. You first actually pack this string number into a tuple, right? So it will be having a tuple of 10, 20, and 30. And then you will perform unpacking, which is you will have x, y, z equals to this tuple, and then x will be having a value of 10, y will be having a value of 20, and then z will be having a value of 30. And if you're curious, you can just print it out and see. Okay, so print 30, and then, oh, oops, print z, you'll get 30. Okay, so that is what happened. Oh, okay, I forgot to run this. Yeah, okay. So also we can exchange the value of variables, right? So this is interesting, but it is doing the same thing. So like on the right side of the variable, just pack it into a tuple and then unpack it again. And then so in this case x zxy is like 30, 10, and 20, right? And then you just sort of pack it and unpack it for x, y, z, and then 30 will goes to x, 10 will goes to y, and then 20 will goes to z. And then we print this x, y, z, then it will be 30, 10, and 20. So yeah, I mean this language is just very easy to deal with, right? With all those features, then and also that is probably why Python is so much shorter than other kind of language, because it can sort of mixing multiple line comments multiple line code into like one line. Okay, and yeah, so imagine this. Let me expand more on this packing and unpacking idea. So add star to make a variable into a list. So we also have an idea like this. So you have a range 10, right? So range 10 is just like a range from 0 to 9, right? And that is sort of a tuple or something. But yeah, here, if you add a star before a variable, then you can actually make it into a list. And by doing that, you can do something like first, second, and then rest. So by doing this, you can get like you print first, and then you get number 0. You print second, you get number 1, and then you print rest. If you like, yeah, if you want to only unpack first two elements in the tuple, or like in a specific list, then you can do something like this. And then yeah, just be careful of if you add a star in it, the data type will be list. Okay, and yeah, with that you can do similar things. So if you want only unpack the last element in that range, and then you just do star begin, comma, last, and then if you print last, then it will give you 9. Okay, and then what you can also do is first, middle, last, and then you just pick out this first and the last elements in that specific range, and then you leave the rest in the middle. Okay, so yeah, that is that for tuple. Any kind of question or concerns before we move on? Okay, I see no questions. All right. So yeah, the next topic will be list. So we sort of introduced the tuple. We have talked about lists, but we have not actually defined it or like talk a lot about it. So now is the official time to do it. Um, so yeah, if you have a tuple, you can convert them into a list using this. This is called casting, but this is an idea of you have a list and then you have bracket. Then you just pass in the tuple, and then you just print a list, and then you will get list. Okay, so yeah, that's how you convert from a tuple to a list. And yeah, just to be this is the twins, right? So if you can convert a list into a tuple, then you can convert a tuple. If you can, sorry about that. If you can convert a tuple into a list, then you can convert a list into a tuple. Then those are similar stuff. So you can do this tuple as well, and then you just print a tuple. Then you'll just get this like 1, 2, 3. Okay. And then you have this. You can also convert a range into a list. So yeah, the idea is range is not a list, but I think it is pretty similar to list. Yeah, so just treat it like that. And if you want to perform any conversion, you can just easily do it, right? So yeah, so you can do this with this, then you can initialize it a list pretty quickly. So what you can do is C list is equal to list range from 1 to 20. And then in this case, it is from 1 all the way to 19 because the right side is not included. And then the comma 3 means step length is 3. So the number will be like 1, 4, 7, 10. Yeah, so those numbers. Okay, and then list append and extend. List append and extend means that you can append a list, and then append means just add elements, right? And then extend also means add elements, and there is a difference between that, and I am just going to illustrate you with code. Okay, so this append function. So what I will do is, for example, we have a list is equal to 1, 2, 3, and then we can just append a 4, right? Then the list will be 1, 2, 3, 4, right? We can also append the question mark, right? Yeah, so then you're just gonna the question mark is on there. But when you can append different stuff, right? But like when you append a tuple, then the element of, for example, this is index 0, 1, 2, 3, 4, 5, right? So on index 5, this is actually a tuple, right? And then on index 6 here, when you append it, it is actually a list. So yeah, the idea is whatever you are provided in the append, it will just be there. It will just be there in as a 就是当做一个整体 as a whole, right? So if you try to access this, it will give you a tuple, right? So this is exactly the stuff here. right? And then you print a list 6, and then you can have 100 and 200 and 300. And yeah, for those of you who do not know, we can, there's a question. I will give you like 3 minutes to think about it. How do we access number here? For example, if I actually want the number 20, or this one, the number 200, or like any kind of number in this, what do we do? Like, what is this thing that we want to do? I will give you like 2 minutes before I actually review the answer. And this is like a thinking practice. And if those of you who has the answer, then you can try to type in chat. And yeah, I mean, no one wants. There anyone wants to share, or by using the term insert? What exactly does that mean? So we need to access this number, right? So what I mean is, for example, I have a list 5, right? And I actually want to print out this number here. For example, I want to print out 20. How would we do? So yeah, I am gonna review the answer. This idea is called 2D arrays, and if you have not heard about it, it is fine. It just means a list in a list, right? So this is a tuple in a list. This is a list in a list. And if you try to, for example, you have a bracket out there, print the type of this variable, you can see it is a tuple, right? So you can treat this whole thing as a tuple. So you can do like, for example, A is equal to A list 5, right? And this here, A is a tuple. If you want to access the second element in that tuple, what you will do? You will just do A1, right? Right. So if you go ahead and print A1, then you can have number 20, right? And when you get more sophisticated at it, you can just do something like this. So a list 5, and then the next is 2. For example, if I need 30, right? If I run this line, oops, what did I do? Oh yeah, I just clicked. I just run twice. So yeah, if I do 2 here, then you can just get 30, right? And this is very similar. If you have 6, right, and then you do 0, you'll get the number 100, right? Like this is the idea. And more on that, a list dot append, and if you want to do something like this, 1, you want to do A, B, C, 3. I am just gonna change this to some random number like 47, 384, and then you print a list, right? And you're gonna have sort of this weird thing here where you have a list, right? And this element is a tuple, this element is a tuple, this element is a list, right? And then in this list, there is also a list before we actually get into those elements. And the way we do that is we just do this because those are nested lists, right? The idea is you just keep indexing it. So you have this 7 as the last element. And then if you want to get this list, then you count like 0, 1, right? So you just do, oops, I'm gonna do inside the bracket 1, right? Yeah, and then the 1 means right now we have this string list with like A, B as a first element and C as a second element. So you do 1 again, then you can find this character C. Okay, so yeah, that is like nested list, and it works the same for tuple. I'm just not gonna illustrate here. Basically, it's the same thing. It is just that you cannot append, but like for indexing, like in terms of indexing, it is the same for tuple. Okay, but like you cannot do a append on the tuple. It will give you an error. Okay, so yeah. But here is the difference between append and extend. So the extend means that if you have a list, for example, 5, 6, 7, and then you pass in another list, right? Append will just make a list into a list, right? So like nested list. But extend actually means that when you actually print this out, you can see those ones are flat, right? There is no nesting in this kind of list, right? So that means that you sort of just take each element in the bracket, then you just add each of those elements in the list, right? And then you can also do this, right? B list dot extend, and then you have a range, right? Like starting from 57 to 89, and then step 10, then you can just have those 4 numbers extended on the B list. And if you want to actually do an experiment here and see how this library works. So if you change this to like a flour, right, bread, and see how that goes. Well, no, it actually only extend one level of the tuple, okay, of the list. Okay, so it does not actually nest those extend. So it only does one level of extension. So yeah, that is something to keep in mind. Okay, so yeah, that is the difference of extend and append. Okay, and yeah, notice that both append and attend just add elements on the last position of the string, not of the string, of the list, right? So like it appends, just append on the end. Okay, so also you have delete list tuple elements. And by delete, I mean, for example, if you have B list, okay, yeah, I'm just gonna rerun this because B list is changed. So yeah, if you print B list, then you have this number here, this list here, 5, blah, 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 blah. And then if you try to delete, delete B list with a element, uh, using index, then it will specifically delete the element in that index. So for example, in this case, the element 0 is 5, right? And then that is be deleted. And the entire length is shortened by 1. And then the first index, the first element is actually now number 6, right? And then you can also do this, delete B list and then colon 2, right? That means you just erase half of the element in the list. It is sort of like miaba, right? One snap, and then half of the element is gone. Okay. So yeah, that is the similar idea. So you can also use this kind of indexing, and then you just sort of delete like from 0, then 2, 4, 6, like those are all deleted. Okay, so yeah, and then you can also do this. You can also do that for normal variables, but it is not usually used. But yeah, this is something you can do. So if you have name as Ray and then you delete that variable, and then if you want to try to print it again, then you can see name is not defined, means like the compiler is saying I do not have seen this variable anywhere, right? I do not seen this variable as a variable on my stack, right? So yeah, on my stack means just on the memory. Okay. Yeah, so I just want to comment this and so that it can be run. Okay. Yeah, so there is also a method called remove. So remove means it tries to find the element in that list and tries to delete it. And it is it for the first instance of remove. Okay, so for example, if I have a list with like 2 10s, 2 20s, and 2 30s, after I do clist.remove, then the first 10 is gone. Okay, and then if I call remove again, then the second 10 is gone. But after this, if you want to try to remove again, then it gives you an error because remove x is not in the list, so 10 is not in the list anymore. There is no purpose to remove it because you cannot remove nothing. Okay, so that is the remove function. And you can also have this clear function where it just removes everything on the list, so it makes the list into an empty list. So I figure that this is quite self-explanatory. Okay. Oops, what is happening here? Oh yeah, change. So the next we're gonna talk about change the value of an element in the list. So yeah, in terms of lists, those lists are very flexible, and you can actually change the values of an element in the list. Okay, so you can do this, right? You print a list. Yeah, just gonna print it again. Yeah, it has all those different sort of things in it. And then if you print it, it has this. And then you change this a list with indexing. So with index 0 is equal to 0, then if you try to print it again, this entire thing, the first element here is changed from 1 to 0. Okay, so that is change things using index, right? And also you can change a bunch of things, right? So for example, if you have b list equals to list range from 1 to 6, which means 1, 2, 3, 4, 5, right? And then you just print b list, and then you do b list 1 to 3, which means 1 to 3 means 0, 1. So 2 to yeah, so 2 to 3, right? Because B list 1 to 3 means the second element and the third element, right? Because the number 3 here is not included. Uh, the, the third index, the index 3 is not included. So it's just from index 1 to index 2. So it is, in this case, number 2 and number 3. And then we are actually trying to replace it with a list and see how that goes. So if we replace that, then it will actually be unpacked, and then we can actually get A and then 5 and then 9 as like different list items in that list. Okay, so yeah, the next thing, B2 2. This is a little bit weird, but this is basically saying that you start from 2, you end from 2, and then you're just using that as like sort of the idea of index, right? So you're basically saying that you are putting the cursor on the index 2, right? And then you're trying to insert a bunch of stuff, right? So this is pretty similar to the idea of inserting. And then you can insert literally on any kind of index you want. And then the way to understand this index is that the first element that is passed in to the list has the index 2 in this case, right? So like, is it, so like the 1 is 0, and then A is 1, and then this one is 2. Okay, so yeah, that is the idea. And then other index have like moved back for like one place. Okay, so yeah, that is that. So yeah, you can also sort of perform the delete. You can do B list 2 to 5, which means you're selecting the second object. So like from 0, 1, 2, right? So the third one, and then all the way to third, fourth, fifth, right? So yeah, you're deleting like 3 instances. And then if I run this, you can see here y is deleted, 5 is deleted, 9 is deleted, right? Oh yeah, no, sorry, is x deleted, y deleted, and 5 deleted. Okay, so 9 is still there. Okay, so yeah, so that is the example. So yeah, B list is equal to 2 to 5. 2 to 5 is empty. You sort of delete that as well. And then also you can sort of replace those index with a specific string, right? String will also treat it as list item, except that it is a list of string. It is a list of character. I mean, yeah, I will split it into single characters, right? So if you do like B list 1 to 2 is equal to Ray, then you're just basically splitting those 3 letters and then put them into the list. Okay, so yeah, so that is the list. And yeah, other useful functions of the list. So we can have this thing called count, and then it actually counts how many times a certain element appears in the list. And here index means checks the index of an element. It is sort of like remove, but without the actual remove. So it actually only checks the index. And I think that, if the index is not, the object is not there, then the index will give you an error. So pop, the idea of pop is an interesting one. We can elaborate more upon it, and because it is dealing with a very important data structure called stack. Okay, and yeah, the next one. Interestingly, for a list, you can also have a method called reverse, and it actually goes ahead and reverse the elements of your list. And yeah, by the end of the day, you will have learned another method to reverse a string. Then this is what I'm talking about. So you can first convert the string into a list, and then you can try to reverse it using this function called reverse, and then you can just convert it back to string. Okay, and then sort the elements. Sort is a function, so it just helps you to sort the element from like the largest or the smallest. And yeah, so let's actually get into examples. You can have a list here as blah blah blah, and then you can actually count it. And be careful when you have a, for example, this 30 is in a nested list, and those ones will not be counted. Okay, and if you really want to count it, then you will do 0 1 2 3 0 1 2 3 4, right? So you will put this an index, right? So that is list in the list. So you're just still performing list dot count, right? But you're just passing an element in the list, which is also a list. Okay, so this is a little bit of a, raw coding, but like, uh, yeah, you can get the idea, right? So yeah, if I just do index 4, it goes into this list, and we are counting 30 in this list, and then we have only one, right? And if we do not do this, then it will count on the entire list, but not include the nested list. So it will just be 2. Okay, and yeah, here print a list index 30. It will just give you the first index of this item 30. Okay, and then if you do this, if you like sort of specify a range, right? So like you starting from 1, and then you end from 3, and then this index.list cannot find any 30 for you. So it says like 30 not in the list, and then it gives you an error. Okay. And you can also do this. You can just provide a starting index, and then this goes all the way until the end, and then the function will figure out itself where is the next occurrence of, for example, in this case, the number 30. Okay, so yeah, that is that. The idea of a stack. Let me give you a visual picture. So yeah, I want to give you a visual picture of the stack. So what a stack is that this is a good one. Um, let me try to open this. So imagine you have like a sort of bottle, right? And then you're just putting items inside of it, right? So imagine this is an empty stack. And then, the bottle is like sort of sealed, right? With only opening is on the top side, right? So yeah, when you push one element inside of that bottle, then the bottle will have one element in there, right? And if you push again, then if you push a 2 there, then the 1 can never be accessed, because the only way that you can get 1 is, first you can get 2 outside of the way before you can actually get 1. Okay, so the idea is you will do push on this thing, and then you will do pop, and then the pop just means that the first element you will see in this stack, which in this case, if you push another a number here 3, then if you call pop, then the 3 will be popped out. And this is the idea, right? Like imagine you have a stack of books, right? And then you just you can only remove or add from the top, right? And if you try to like access the box somewhere at the lower level, right, at the bottom, for example, the whole thing will crash. So like do not do that. And the idea is that the Python list can act as a stack already. And what I mean by act as a stack is that you can sort of you can still access the index, right? So like even though you just call stack equals to yeah I can just write code here. So even though you do this, right, and then you can still access it. You can still do access. For example, you do this, right, and then you just comment out all those, and then you just run, and then you can just have this number 2, right? You can just do have this number 5. I don't actually know what this is, but yeah, you can sort of still access it. But we don't normally want to do this, because we have this stack um, data structure for a reason. And this is sort of introducing, and we are gonna talk about it in like very detail later in the course. Okay, so this is basically saying that you can implement stack using a list. Okay, and then how do we actually deal with it? So you can do here. So this idea is stack is equal to empty, and then you append a bunch of numbers onto it, and then the idea is 1, 4, 5, right? And then you just print out stack. Those are 1, 4, 5. Print stack pop. So what the pop does is just pop out the last element you pushed in, which means in this case you append in, right? 就是说它你把那个，比如说你把最后放进去的那个 element， 你把最后放进去的那个东西，把它扔出去，知道吧？把它扔出去，说白了就是把它扔出去。然后呢，它剩下来这个 list，它剩下来这个 stack 里面呢，现在只有1、4这个东西，知道吧？然后如果说你需要就是想要了解更多的 stack 的话，那其实有一个 其实有一个小 exercise，如果今天有时间的话，我还可以帮你们再稍微介绍一下。好吧。So this is the idea of using stack. So you can append, and then every time you append in this picture, you can imagine it as push, right? Because you're actually adding from the bottom. Yeah, I mean you're actually from adding from the last element of the list. Sorry about that. Yeah. So you basically just append 3 elements, and then you try to pop, and then you can just keep popping, right? You can just print stack.pop, and then you just can do that again and again. And then imagine if you pop every element, you have pop from an empty list, because everything is popped. So there is actually nothing in there. If you print stack, then it is sort of like an empty list. And then you try to pop it, then it will give you an error. Okay, so that is the idea. Okay, so the next function will be print a list, and then you can do a list or reverse, and then you can do it again. Then yeah, this a list is originally like this, and then if you do reverse, then this one is to here, this yeah, be careful. If there is a list, it will move the entire list to, for example, the first index, right? So like the index 1, right? So you'll move this A to here, and then 203 does not move because it is in the middle. Okay, yeah, so if you want to perform a sort on this, it will give you an error because the elements in like not all the elements have the same type in the list, and in this case int is not comparable. Like for example, this list is not comparable. It is also not comparable to a string. So that is something to note. You cannot do this. Yeah, the most ideal way is that you have a list of numbers or a list of same stuff, right? And then you can somehow sort it, right? And then it actually sorts it for you with like very short time. Okay, so that is the function sort, and then you can actually provide a parameter called reverse equals to true, and what that does is actually a reverse sort. So return a list that is sorted reversely. Okay, so yeah, that is the idea. So this one, C list equals to blah blah blah. We have a bunch of names, and then C list of sort key is equal to lens, right? This len is a function. It is a keyword called lens, and it actually gets the length of each string and actually try to sort it, right? So yeah, so this is length 3, 4, 4, and then 8. Yeah, so so that can be sorted as that as well. We are gonna talk about more in terms of like functions and stuff later in the course. So right now this is just introduced, and then you can just like sort of remember that when sorting, then you can provide a key for sorting, right? And then you can provide a key for like, what do I want you to sort on, right? Like if I don't provide a key, then it will just sort on, this alphabetical order of those strings, right? And if you're curious, I can show you, or you can run it yourself. So if I run this, then sort of A is the smallest, E is the second smallest, G is larger, than R is the largest, because it is like the latest in the ASCII table, right? So yeah, that is how it works. And yeah, so today's exercise. The first one: write a Python program converts a given string list to a tuple. Okay, so for example, original string is, for example, Python 3.0, and then the class is string, then convert the set string to a tuple, and you just sort of convert it, and then you print out the list tuple. Okay, and then that is the first one. It should be pretty self-explanatory. And then write a Python program to compute the sum of all the elements of each tuple stored inside of a list of tuples. So what you have is you have a list, right? And then you have like a bunch of tuples as the elements of that list, right? And then you are sort of like summing all the elements of each tuple inside the list of tuples. So in this case, 1 plus 2 will give you 3, 2 plus 3 will give you 5, and then 3 plus 4 will give you 7, right? So that is the case. And then the other case is original tuple. List of tuple is something like this. And then, oops, yeah, and then you just sort of delve up those answers. 1 plus 2 plus 6 gives you 9, and then blah blah blah. Those, and then yeah, just consider that sometimes the tuple have different lengths, right? Sometimes the lists have different lengths. So yeah, that is the thing that you want to keep in mind. Okay, so good. The third exercise, given 3 digits A, B, and C, and the task is find all the combination of these digits. Yeah, I would say this is actually permutation. Okay, so yeah, this is actually a permutation, and then yeah, given 3 digits A, B, and C, task is to find all possible. Yeah, I would change that to like permutation from these digits. And yeah, so that is the task, and it is sort of ideally using a for loop. And there's also external libraries. If you can do research on that, then you can also have like a pretty simple solution of those. Okay, so yeah, the next exercise, the last exercise, is write a Python program to remove repeated elements from a given list. So for example, if you have like 1 to 1, right, and then it is sort of somehow repeating, and then you have to remove it, so that in this case, like those repeated items needs to be removed. Okay, so yeah, that for today's lecture. And the exercises, is there any sort of questions or concerns, or yeah, anything? Just let me know. Not much people actually wanted to talk today. Okay. Yeah, I mean, yeah, that is all I prepared for today. Also, stack. Yeah, in terms of stack, let me actually gives you stack preg match brackets using stack. So yeah, um, this is sort of yeah. There is the idea of this this stack thing. So when you have a bunch of brackets, right? So let me add one here. So let's say you have this. You randomly you randomly have a bunch of brackets, and then you can tell a you can tell if this uh, you know this thing is valid, right? So like for example, you have a sort of expression, and then you have a bunch of brackets. You can have those sort of things like this, and then you can see like if those brackets are actually nested by using a stack. So right, you can have this. you know, you can have a lot of fun with this, right? So this can be done using a stack, okay? And then like, right, like you can have this string of brackets, and you can have a program there to tell you if this like if this set of brackets actually make sense, right? Yeah, so that is one classic practice for stack. When we actually talks about stack, then we're gonna officially introduce it, or yeah, I will probably give you guys this exercise by then. Okay, so yeah, that is in terms of stack. That's a little bit of storytelling. Okay, yeah, is there any kind of questions before I actually conclude today's lecture? Yeah, so I will, for example, wait for like 2 or 3 minutes before you guys, if you have any kind of concerns or questions. And yeah, also tomorrow I am gonna talk about this idea called dictionary, and then after that, I hopefully will give out an assignment by either end of tomorrow or the day after, and I sort of like giving you this because of you know the homework are usually not graded or any kind, and more practice is always good for learning programming, because those are actually important. And yeah, that is pretty much it. That is my plan for tomorrow and the day after. Yeah, and if there is no more questions, then I am just gonna, conclude the lecture here. All right, all right. Last call. Any questions before I actually leave? Nope. All right, all right. Seems like everyone is pretty happy with my lecture. All right, all right. Yeah. Okay. So that is it for today's lecture. I will see you on tomorrow, 10 a.m. All right. Okay.
Thank you.
Thank you.
Have
Yeah.
a
Thank
good
you.
Yeah.
day.
Bye.
Yeah.
Bye.
Thanks. Bye.
Have a
Have a
good
good
day.
day. Yep. Have a good day.